This is distances number 4, and we are trying to find a point on the graph y equals x cubed that is closest to the point 4, negative 1. What's the distance between the 2 points? So I graphed y equals x cubed and plotted the point 4, negative 1, and then just sketched in a line that looked like it was a line that connected 4, 1 to a point on x cubed such that this line was the shortest. I could draw it anywhere to x cubed, but I want the one that's the shortest. So you can see as I trace through here some options for different places I could draw this to, and I put this in approximately the right spot for it to be the shortest. So the main idea here is that you have the constraint that your point xy has to be on the equation y equals x cubed. So it's not just any 2 points on the xy plane, it's a point that's on the graph y equals x cubed. So that's my constraint. And then the thing that I want to minimize is the distance between the 2 points. So the distance formula is a good formula to use here. The distance between 2 points is equal to the square root of x1 minus x2, or x2 minus x1. The order doesn't matter because you're squaring it, plus y1 minus y2 squared. I think it's more commonly written as x2 minus x1, but again, after you subtract it, you square it, so the order does not matter. So my 2 points in this case are 4, negative 1, and x comma y. So I'm going to do let's do x minus 4. We'll treat this as our first point and this is our second point. So x minus 4 squared plus y minus a negative 1. So y minus a negative 1 is really y plus 1 squared. So this is the equation I want to minimize, and it's almost good to go, except for that we have a y variable in here, so we need to use the constraint to substitute that in there. So the distance is equal to the square root of x minus 4 squared plus x cubed plus 1 squared. And this is the equation we want to minimize. Now you could multiply this out, x squared minus 8x plus 16, and whatever this one comes to, and combine like terms, but you're putting it into the calculator and you can put it in just like this to minimize the distance. So then the only thing we want to know is if we have this point that's on y equals x cubed, looks like, I'm just going to guess 1. 1 looks to be an integer that's pretty close to this. And if x is 1, y is 1, because remember y is equal to x cubed. And then this is the distance. So if x is 1 and y is 1, and then I have this equation here, so 1 minus 4 squared, 1 minus 4 is 3, 3 squared is 9, and 1 plus 1 is 2, and 2 squared is 4, so this ends up being the square root of 9 plus 4, or the square root of 13. And I got that by doing the square root of 1 minus 4 squared plus 1 plus 1 squared. The square root of 13 is approximately 3.5-ish, So this overall distance is not very big. I would say that's a reasonable amount. You should probably do one more guess, but just to make this video short, I know that this length of the line isn't all that long, so I'm just going to put it up here at 10. I don't think this line could possibly be 10 units long, but I want this to be a little bit high, and I'm trying to minimize the distance. So that's the name of this variable, and this is the x coordinate on y equals x cubed. Okay, so let's graph it. X coordinate, it's not very big. It's near 1, so I'm just going to put this out to 5, and even that might be too big. So I'm going to put in y equals the square root of x minus 4 squared plus, oops, I need another parenthesis right here, plus x to the third plus 1 squared, end parenthesis. And my window, I only want 0 to 10 and maybe 0 to 5. Whew. So even 5 was too big. I'm going to adjust that window and just, no, it was a 10 that was too big. Make this, oh, I did that backwards. It was 0 to 5 on the x-axis and 0 to 10 on the y-axis. So that's a little bit better, and 5 is a little bit big, but this will suffice in finding the minimum. So I'm going to move to the left of the minimum and press enter, and move to the right and press enter, and press enter one more time. So remember that these points are x, the point on y equals x cubed, and the y value here isn't really the y value, it's the distance. It's the length of this line segment. So when the x is about 0.8, which looks good for this point, the distance between 4, -1 and y equals x cubed is 3.5. So this line here is 3.5 units long. I don't know what the y value of the point is, but I can find it because I know that y is equal to x cubed. But remember that this, it's x's, distance. So this point here is 0.82. The x value of the point on the function is 0.82, giving us a minimum distance of 3.538. So I have a graph that looks about like this. And the minimum distance, or the minimum x value, was 0.824. That's the x. And the y is 3.538, which is the distance. 3.538. Remember, points on this graph are x coordinate on the y equals x cubed graph, comma, the distance from points on this graph to the point 4, -1. So then my final answer, x is 0.824, y is 0.824 cubed, because y is equal to x cubed. So I'm going to take the x value here, 0.824, and raise that to the third power. And so the y value is 0.559. And the distance, the minimum distance, is 3.538.